to personally ask you to check out mentally. Yeah, focus. Check out mentally.
Dude, that's literally
not even check in. No, check out this class. Check in. Focusing on. When you ever check.
Yeah, when you ever.
I'm taking some of my advice. Why?
Okay, I have 3 periods in a row with you. In those 3 periods, you are basically not even there.
Yesterday, they were talking to the man's guy. Have you ever done your homework by yourself? Without Slater? Or any class?
About most of the academic given 5-1.
Okay, we got 1 paper. I got 2 papers.
How many topics we're doing for advanced camp?
5.
How that works is I went this way, that way, that way.
That's what I did. I went this way. Okay.
Hey, look at Tyler's running basketball too.
Tyler, you're in basketball?
Just for Friday. I'm serious.
Yeah.
Let me take it
Nice.
now. I'm serious about it.
Yeah, they're pretty good.
Mine's not even a flannel. I don't have like a real flannel.
Let me take it. No, I
It's like a first target, right?
I agree. You worked on it today, guys. You?
Big basketball game today, man?
Yeah, you know it.
Are you gonna slam?
Oh, that's right. She said she's gonna give us time. And then she said if you only have like 1 done, then you gotta do some on your own. And if you have 1 done,
Alright, hey, take a seat.
alright. Game day.
Woo! Every day.
That's right.
We're gonna do notes.
And I'm gonna get.
Oh, that's all.
Okay, alright, hey. Okay, we're gonna do a couple notes today on this topic here. We just have a couple things I want to go through. About the last maybe 10-15 minutes of class, I'll kind of let you have some time where you can work in the page. It's not 312, I don't think. It's I didn't even put it up there. I'll put it back up on the board here in a little bit. It's the page 324 stuff. All you have to do on there was syntax divider, long divide. They told you what to do. That's all you have to do. Nothing else. Don't graph. Don't find the remaining roots. Nothing. Okay. Today, our new topic is to go further. To take like long division and go further with it, or synthetic division and go further. Okay. That's kind of what we're going to look at today. There's a bunch of different topics that we're going to hit today. So we're kind of like putting pieces of the puzzle together. Right now, as of this moment, you should be able to graph polynomials, like rough sketches, knowing where x-intercepts roughly are, how to find y-intercepts, how to factor it apart, how to figure out if it's symmetrical or not, how to figure out turning points. The only thing we don't know right now is like where those hills and valleys are. I've hinted at what we're going to be doing. Okay, today we're going to take what we've been learning the last 2 days in here, which has been, I know it's been kind of a weird like off-topic thing, where we're doing the division stuff. Well, what we're going to do today is take a polynomial that we know is non-factorable and find where the x-intercepts are. So before, you guys could factor it apart and figure out the x-intercepts. Today, we are going to look at how to find them if we don't know them. Does that make sense? So it's kind of putting that piece of the puzzle together, like why did we cover division? That's what we're going to fit in today. Okay? Now, the whole point of this is called the rational zero theorem. And that's like our main goal. We have to figure this out. That's going to lead us into finding the roots, like the actual x-intercepts. That's what a root is, or it's called a zero, right? Then we're going to look at this weird side topic, which it's not a huge deal. It's not. For some people, they really struggle with this concept. It's just this like little thing we do off to the side as a check. Like, did you find the right roots? Did they make sense for your problem? So that's what we're going to do today. And I know this is not a big topic. I'm not going to try to cover this. I'm not going to like go overboard on this, because I know some people they're not going to like it because they're just not going to get it at first. And then I'm going to show you this idea of what we did synthetic division. I want to show you this idea of synthetic substitution. You will need a calculator at some point today. So if you have one, you'll need it to take it out. If you want to borrow one, I have about 10 over there. Okay, you will definitely need a calculator at some point, so take it out. And then if we have time today, I don't know if we'll get to it, I want to talk about imaginary roots today. All right. Okay, all right. We understand what we're going to be going through today? Okay, it's not bad. This is pretty easy stuff. It's going to be kind of filling in what we've been learning. Okay, all right. I'm going to pick a problem from the book. In fact,
Jonah, you can pick it.
All right. will actually have roots to them. Some of these won't. So, all right, do those. Any of those times are over here.
F parentheses x parentheses equal sign x to the third plus x squared minus 4x minus 4.
One sounds right, Carver. Thank you. All right. Okay, all right. Now on this problem, now the good part about this problem is that it's somewhat factorable. So we can definitely check this one in the end. Okay? So it was actually a really good choice. We can actually factor this in and figure it out. Okay? All right.
That's right.
All right. Okay, so let's work through this how we would have done it like the old method, and then I'm going to show you the new kind of method today. So this is a good way to kind of tie in what we've previously done. Okay, if we're going to group these together, like grouping method, we can actually factor this thing apart so we can figure out x-intercepts on this graph. Agreed? Like figure out roots, zeros, whatever you want to call it. Okay, so on this first red part, what do these have in common?
X squared.
X squared. So if I pull an x squared from both of these, what I'm left with, there's actually two things here. I'm left with x here plus 1. There's always a number up front. Now in the back, what do these two things have in common? A negative 4. So when I pull out a negative 4, I'm left with an x plus 1. Because I take negative 4 and I divide by negative 4. Okay, now do you see that they definitely have something in common? Okay, so the idea is that if they have something common, I can actually factor it apart. I can pull that apart where I can pull the x plus 1 out back. And what I'm left with when I pull the x plus 1 is these two things, which is x squared minus 4. Does that make sense? Like taking the x plus 1 off, and I'm left with these two things right here. Yeah, exactly. And so the idea is that on this problem, this is a difference of squares, so I pull that apart. So that's plus minus x and x, 2 and 2. And in the back, I have x plus 1. So on this particular problem, there is 3 roots. There's 3 x-intercepts. They happen to be really nice numbers. So what are the x-intercepts on this graph?
Plus or minus 2,
Yeah, exactly. Plus or minus 2s. Doesn't matter which one. And then the negative 1. Okay? Now, look how many roots there are. 3 of them, right? What was your biggest power earlier? 3. That is a property of all polynomials, that they'll have the same number of roots as there are the actual like n degrees. Okay, and that's what I mean by that. Even if you count the ones that are like repeating, like double roots or triple roots, they will typically have about this many. Even if they're imaginary roots, there's still going to be 3 possible roots. Does that make sense? Okay, because this thing has the potential of hitting the graph 3 times since it's going to curve, it's going to turn twice. Okay? Now, I'm not going to go through the graphing or anything like that. Now, the goal today is to learn our new process. It's to learn this idea of what a rational zero theorem is. I've introduced it, I think, yesterday. Our goal is to look at that process, and we're going to come back to this problem and to show you that those numbers are most definitely the x-intercepts. So, like, if you were doing a problem and you couldn't factor it apart, you could do this theorem to actually find these same numbers here. Does that make sense? So that's where it's going to come into place. Like, this problem is factorable, so it's kind of nice. We could do it that old school way we did it like 2 sessions ago, that page 312 stuff. That's how we did it. Okay? All right. So let's actually look at this process. I'm going to use this problem. A good choice on this one, so we can actually see what the numbers are going to be. All right. What do we have? We have x cubed plus x squared minus 4x minus 4. Right, so this is my function. All right, so now by the zero theorem, here's how this works. What I need to look at for this rational zero theorem, I look at the number out front. What's the number out here? 1. And the number out back? 4. And I don't care if it's positive or negative. I'm just looking at the digits themselves. Does that make sense? So 4 and 1. Okay, now how this works, the book gives these like letters. I don't really care about that. This number is going to go on the top of a fraction. This number will go on the bottom, whatever it is. Okay? Does that make sense? So whatever those numbers are, you're going to put them on top and bottom of the fraction. Now what I want is I want to break this number up and the bottom number into all the possible roots that can, all the possible factors that multiply to give you those numbers. So what are all the numbers that multiply to give you 4? 2, 4s, and 1. Agreed? 2 times 2, 1 times 4. So these are the different numbers that can multiply to give you 4. Okay, I just list them. Okay, what about all the numbers that can multiply to give you 1? 1. Okay, it's 1 and 1. Okay. All right, so now what we're going to do is we're going to make every possible combination of these numbers in this order, where these are the top numbers, these are the bottom numbers, so you make every combination you can. And we have to put plus and minus signs out front of them. So we'll start with the first number. So if I put this one over the bottom number, what do I get? 1. So it's plus or minus 1. Okay? All right, take the second number, put it over the bottom. What do we get? 2. Okay, so it's plus or minus 2. Take the back number, put over that. 4. That's plus or minus 4. These 6 numbers are the only possible x-intercepts we can find that are rational numbers. Now, what does rational mean? Say it again. Real numbers. Rational. They're not imaginary. They can be fractions, so they can be decimals. But these are rational numbers. This process, what I'm doing here, will not give you like irrational numbers. It will not give you things that are like square roots or anything crazy. It'll give you nice, easy fractions to work with. Okay? The problem is, I know sometimes this graph, this problem, could potentially hit at weird decimals, weird spots, because these are random like drawings, right? They could go through a random spot. If we do this process correctly, it will help you find where those random spots are. That's why I like this. This is just kind of an easy thing. But now, how many numbers are there? There's 6 numbers I need to check to see if they're possible rational roots. Now, we already know what they are. What were the numbers earlier? -2, 2, and -1. So we know those are the spots. So of these 6 numbers, at least 3 of them did work. The problem is you have to figure out what they are. Because on a normal problem, we weren't able to factor it like that over there to figure them out like right away. So to do that, we would have to divide. You'd have to divide to check each single problem. Okay? So you'd have to divide. So what I do is I usually start with one of the small numbers and work my way up. Okay? So I'm going to start with the number +1, and I'll check that one first. Now, how do you think I'm going to divide this? What process do you think I want to use? Synthetic or lone division? Synthetic. Way faster. I can see what the remainder is, and I can cross it out or use it. So the first number I'm going to check to see if the number +1 is actually a root. And so what I'm going to do is I'm going to put the +1 in the house. Okay? I'm going to put +1 in the house. And then going across the top, I'm going to put my function. Well, what's my function over there? Yeah. 1x cubed, 1x squared, -4x, -4. And I'm going to do synthetic division and see what my remainder is. If the remainder turns out to be 0, that number was a factor, is an x-intercept. That's what I'm doing here. Okay, so let's double check this. Now, I already know from looking over there, it's definitely not. So we should definitely guarantee that I'm not going to get this for an x-intercept. The remainder will not be 0. So we already know that. Okay, so what was the process for how we do completing synthetic division? What was the process we talked about yesterday? Straight down. Oh, 1 in the box. Yeah. Drop the certain number straight down. Now what do we do? Take it times the number in the box. So 1 times 1 is 1. Add them straight down. Multiply by the number. Take this number times the number in the box. Add them straight down. Multiply by the number in the box. Add straight down. Notice, did my remainder turn out to be 0? This is not a factor. Throw it out. So now we're down to 5 numbers we need to check. Now you're probably going, oh my God, you're kidding. I have to do this 5 times. No, because once you find the first one, now it's easy after that. It'll be super easy after you find the first one. So that's the process. Like, it may take you a while to find the first one, but once you do that, it's really simple after that. Okay? All right, so let's keep going. So what do you think the next number I'm going to check? -1. I have to check that number now, because there's always 2. Okay, so I'm going to check the -1 now. That will go in the box. My leading coefficients are 1, 1, -4, -4. And I'm going to synthetic divide this thing. So same process like we just did a little bit ago. drop the first number down, multiply by the number in the box, so 1 times negative 1, add straight down, multiply by the number in the box, add straight down, multiply this by the number in the box, add straight down. You notice? Was it a root? Yes. So this was a root. That was a root. Negative 1 word. Questions?
So, while you were doing that,
Yes.
I just plugged 1 in as x's and see if it was equal.
Exactly.
Like,
Okay.
what?
We're gonna talk about this. You're already ahead of me. Because what you were doing is called synthetic substitution. We're gonna talk about that too. That's what you have your calculator. Okay, so we're gonna
So calm down.
I'm gonna come back to you because I wanna know what you found. Okay.
Alright.
Alright. So, hey, did everyone see what I just did there? Okay. We are definitely gonna get back to that because that's one of our little shortcuts today. Alright. Alright, so does everyone see that I found a 0? Okay, I got a remainder of 0. Now, if I were to write this down, as like what this remaining function is, like the actual answer, so if we were to long divide, what would be on top of the house? This is the constant number, agreed, because that was the remainder. So this is the constant. Then what the rest of these are, this is a 0x, so that's 0, right? And then what would, so that would be 0x, and then what would this be? X squared. X squared. Now, if there was a number in the middle, so I know we have a 0x there. Okay, if there was a number in the middle, if it was a normal trinomial, I would try to factor what this is as a normal trinomial. Okay, but it's not, because what type of problem is this? The difference of squares. Every time you do this problem, you actually divide and found a root. Whatever's left, this is called the reduced function. It's whatever our first function was, but it's been reduced now. We took out the negative 1 out of it. This thing is usually factorable. It's so weird. It always works out to be factorable in the end. So I can factor this apart and find the remaining roots without having to do long division anymore. Okay? So I can take this thing, and it's a difference of squares. So I can factor that apart. Plus minus, x and x, 2 and 2. And now I found the remaining roots. Positive 2 and negative 2. And I found them really, really, really fast. I just found every single root to this problem in a matter of like 2 steps. By just finding the first one. Okay, does everyone see how that works? Now, if this is a trinomial, I would try to factor the trinomial part. Let's say the trinomial was non-factorable. Well, then guess what you can do? You can do the quadratic equation, negative b plus or minus, because that will give you the other roots. Because if you have a trinomial, you can always do that quadratic formula to figure out the remaining 2. So you wouldn't have to factor. You wouldn't have to keep going with this division thing. Okay, and the best part about doing like quadratic equation or trying to factor this remaining thing apart, this reduced function, is even if the numbers turn out to be crazy decimals or square roots, the quadratic equation will guarantee that it will find you your answer. It'll guarantee the correct number. Okay. Questions with this problem? We're going to do another one like this. Now, here's the thing. Tyler, you did bring up something that's super interesting. You brought up the fact that you tried plugging in a 1 into my function, right? So you just took this 1 and you plugged it in. What you didn't realize is that was a process called synthetic substitution. It's avoiding dividing. Okay? So if you didn't understand what he did, he took this original function, that's x cubed plus x squared minus 4x minus 4, and what he's going to do is he's going to take my function and he plugged in a positive 1 into it. So he plugged a positive 1 into all the x's. What did you get when you plugged in a positive 1 into that thing?
6.
Yeah.
Or near 6.
It gave him 6 on his calculator. He just typed this in. He literally typed in 1 to the 3rd power plus 1 squared minus 4, negative 4 times 1 minus 4. And it gave him 6 out of it. Negative 6. Now, okay, do you see that? Now, because he was checking like the number 1. But here's the thing. I want you to look at something. When we synthetic divided, what was the remainder? That's crazy. Every time you plug in one of the numbers, like one of the roots, the potential roots, one of these into your function, you just plug it in using a calculator. You hit enter. it will actually tell you what your remainder is. Why that's useful. You don't have to synthetic divide anymore. You can do synthetic substitution, and it will tell you what your remainder is really fast. It will tell you, are you going to hit 0 on the x-axis? Are you going to hit like 0? Are you going to hit one of those roots by just plugging in the number? So if I were to do the same process, plug in -1 into my function. So I took this and I plugged in a -1 now. Guess it would give me, if I were to plug in -1, it would give me 0. And so now I know that's a root. So I know -1's a root. So the idea that synthetic substitution, it told me that -1 was a root. So that means that I have to do synthetic substitution or long division. Because what I need to do is I need to reduce this down to get what this thing was on top of the house. Because then that will tell me what the other ones are. Because once I find 1, it's easy after that. I found 1. So you are allowed to do that. You are allowed to plug numbers like Tyler did, see if they give you 0. Because that is faster, agreed? Than synthetic dividing 12 times to figure out a number that works. So that's why I want you to take your calculator out, so that you can type this in. And here's the best news. So can I see your calculator? On your calculator, okay, when you type in something and you hit up, it actually puts the last thing you just typed in your calculator back on the screen. So you can use your arrows and just change the numbers here, here, and here, and hit enter again. And it will keep spitting out answers. You just hit enter, see if that gives you 0. No, it didn't. So you hit the up arrow, it puts your function back on the screen, you retype in the new number that you want to check, you hit enter, and you're looking for the one number that will give you 0. You can do this in a matter of minutes to figure it out without having to write down anything. Does that make sense? That's why I wanted your calculator out. So let's do a problem that is non-factorable, so we can check this process so you can see how fast it is to find the roots, even though we can't factor it. Okay? All right. Let's see. Give me the. Give me number 21.
6x to the third plus 25x squared minus 24x plus 5.
That's my function, right? All right, so here's it. So here's my function. That weird thing is not factorable, okay? If you group them together, you could potentially find that it is. But right now, if you try to group these up, there's nothing down here. There's nothing coming there. There's another way to do it. I'm not going to show you that right now. But what I want to do is I want to see if we can find the roots without factoring this thing. Because obviously I told you that right now it's not with the skills you have with like grouping like the first two in the back. Okay? All right. So what we do is we do the rational root or rational zero theorem. I take the first number and the back number, and I'm going to make fractions out of them. So I'm going to put this 5 on the bottom or on the top, and I'm going to put this number 6 on the bottom. Make sense? Okay. So now that I have that, I need to break 5 and 6 up. So what are all the numbers that multiply to give me 5?
5 and 1.
5 and 1. Okay. What are all the numbers that multiply to give me 6s? No particular order. 1s, 2s, 3s, and 6s. 5s and 1s give you the 5s. What I'm going to do is I'm going to make every possible combination of numbers using these as the top numbers, these as the bottom numbers, and I don't want to have repeating numbers. So I'm going to start with the first one. Let's go 5 over this number. So what's 5 over 1? 5. So it's plus minus 5. There's 2. So then I'm going to go 5 over this bottom number. So plus minus 5 halves. Okay, or 2.5. Right? Next number, 5 over 3. 2/3. Right? And then 5 over 6. Okay, so these, right now, I already have, 8 numbers I need to check there. As you can see, it's ridiculous. There's a lot there. And I'm not even done yet. Because there's more. because I still have to take this 1 and put it on the bottom, put it on the top of everything. So what's 1 over 1? 1. So that's 1. Okay, then I go 1 over the 2, which is half. Then I'm going to go 1 over the 3. Then I'm going to go 1 over the 6. Do you see how many roots there are on this problem? There's 16 potential numbers that are roots on this problem by taking the top number over the bottom number. Now, would you agree that you don't want to synthetic divide 16 times? Yeah?
Yes.
So that's why we want to use that idea what Tyler did. Synthetic substitution, where I'm going to use my calculator now. I'm going to type this into my calculator, and I'm going to just take out the x's and put in my numbers into it. So I'm going to take it out, and I'm going to plug in a 1 here. And then I'll try, maybe I'll change that to -1 to all those. And then I'll try maybe 5, and I'll try -5. And then I'll try some of these numbers next, maybe half or a third. And I can just put those in the parentheses. And how you can put it in fractions, you can, in the parentheses, you can just type in 5 divided by 2 in that parenthesis, and then close the parenthesis off. So that's a quick way to do it. And I'm looking for the one that will give me 0 when I hit enter on the calculator. So I'm going to do this with you, just so you can see this. And I'll walk around and I'll kind of show you what I'm typing in my calculator. So if you have a calculator, I'd like you to type that in. Type in your function, but now let's try the number +1 first. I always try the ones first. Then I'll try -1, and then I'll try 5 and -5, and then I'll try these weird fractions. Okay. So 6 parentheses. I'm going to try the +1 first. That's cubed. Plus 25, and I'm going to try the 1 squared. Then minus 24 times 1 plus 5. And so notice how I'm typing this in the calculator. I'm using parentheses on everything. I'm not using any variables. I'm just putting ones in all the spots where there's x's. And I'm going to hit enter and see what my number is. So that's all I do. That's all I do. So type in the numbers, put ones in all the parentheses. Okay. So just putting ones in all those spots where there's x's. And put parentheses down where those are at. And when you hit enter, what do you get on your calculator? So again, I just checked the number +1. So when I type that number in, into my function, it should have spit out of your calculator 12. And you hit enter. That means that was most definitely not a root. So +1 failed. So now what I'm going to do is I'm going to go back through there. I'll hit a little up arrow on my calculator, and I'm going to replace all those ones with -1s. And I'm going to hit enter and see what that gives me on the calculator. Now this is the hard part. For some people, in here, put in the negative sign is really simple. You just put the negative sign in front of the ones, and you can hit enter. Some people, you'll have to hit the shift insert. There's an insert. It's like the delete button. You see it's at the top. You have to hit shift insert. Some people don't have to do that. They can just have a -1. Some people just they just jump to the page and they just retype it. You don't need to do that if you know how to do the insert button.
Go over the line.
Okay, so anyone want to know how to get the insert button on your calculator? There's an insert. It's usually shift insert, right? The delete button. You use for which one?
Okay, wait.
Okay. Hey, does anyone need help entering -1s? Okay, so if I typed in a -1, I'm going to get to that next number next because I've already found one. So when you type in -1, it should give you 48 on your calculator. Most definitely not a root. Now, did anyone not get 48 when they typed in -1? The next number I'm going to try, because I always said I like to try these big numbers first, like these numbers. I'm going to try -5 next, because I already have the negative signs entered. So I'm going to go back and enter the 5 in now. So I'll just bring it back up on my calculator. Does everyone know how to do that, like on a big fancy calculator? Like on these TIs, you can just hit the little up arrow. If you're on something like mine, usually what you have to do is you have to hit the second enter button, like the equal sign button, and it will pop it back up on your screen. And I'm going to go back and I'm going to enter -5s in instead of -1s. Because I think, M, you said it worked? Okay. So if I type in -5, it gave me 0. Okay, does anyone need help typing that in? Alright, so it gave me 0 when I typed in the function of -5 plugged into it. That means that -5 was a root. That means I needed to long divide that, or synthetic divide it, because I knew -5 worked. So I need to figure out what this thing reduces to. So this was actually one of the numbers. That was a root. So I'm going to actually synthetic divide this. We just found it. There's only going to be 3 potentially. Now, once we find 1, you don't need to keep going, because maybe the remaining ones happen to be just crazy decimals. So that's why once I find one of them, like as we found that the -5 worked, I'm just going to use this to find the rest of them. Is that +5? All right, so I'm going to do synthetic division. Dropping down the first number, multiplying by the number in the house, adding straight down, multiplying by the number in the house, adding straight down, multiplying by the number in the house, getting 0. And so my remaining root here is 1 plus -5x, 6x squared, and this is factorable. It's minus minus, 3x and 2x, more than 1. And so my remaining roots that actually work, what makes this thing equal 0 is a positive 1/3, because if I set that equal to 0 and solve, and this one is a positive 1/2 if I actually set that equal to 0 and solve. So those are my other 2 numbers that would have worked. So they were fractions. Makes sense. Okay, you notice how the idea of like synthetic substituting saves so much time, like using your calculator just really fast. So these are the 3 spots where that thing hit the x-axis.
So, to know what x's you use, you just go down 1 power for like...
Yep, so you're going, so when I reduce it, so yeah, so what I do is I would start back this remainder, this is my constant, go up in powers. Yeah, that's how I just know it. I always go back to front, right to left. That way I don't have to worry about what the x's are. I just know they're building up as I go. And then this hopefully is always factorable. If it's not, I do quadratic equation. Okay, we're done for the day. I just want to make sure we did a couple examples. We'll do a couple more of these on Monday. Monday, we need to talk about the Descartes rule of time, which I don't want to make a big deal of it, but I want to make sure that you know what it is. I might bring this problem back up so we can do it for this one. And then we need to talk about imaginary roots on Monday. What?
She's going to be out. Yeah, 7 weeks. This is why he can't do his homework.
I'm starting to think school's like this. I'm saying what's taking so long.
Yeah, honestly, why did it take you so long to realize? That word?
School is
You will miss it. I don't know why you find it pointless. I don't know, maybe it's just a difference mentality. I love reading. That was one of the things I like enjoyed about school. Like some people are like, oh, I don't want to do that. I don't like it. It's kind of fun. It's like I got out of my normal routine. I wanted to sit at home all day. I wasn't. I wanted to learn something.
That's definitely not a joke.
kind of like enraged me a little bit. Like, God, this. And then it just pissed me off to the point where I have to figure it out.
I'm like, oh, sorry, I'm not gonna do it.
You're so different. It was like a personal talent.
Wow, this is hard.
I feel
It's not gonna do it.
But the thing is, I wasn't like, I wasn't.
I mean, I'm not very good.
No, that's why I still coaching, but I wasn't the athlete. So like, I tried to take pride in it. Because I knew I wasn't going anywhere with it.
Warren, I heard you got heated at practice yesterday.
Yeah, I got.
I don't know you. That's what I heard.
I'm not really that worried about it.
You guys remember what happened last year? We played away at Forest City.
Yeah, your dad ripped us.
I'll be so happy.
It's a JV game. He doesn't even coach JV, but he came in the locker.
He walks in.
He's still the head coach. He's
Ripping
still in
us.
charge.
Yeah, he was ripping us.
That was a tough game last year up at their place. That was the one that you guys were ahead.
Varsity, yeah, they were like
or 08 or whatever.
super.
Oh yeah, speaking of that, I gotta
He yelled at us because we couldn't do it.
Yeah, what are you doing right
How
now?
do you do
He's like, you guys can do
I'm gonna
something,
do a
don't
picture
make
of
Brian
this.
do everything.
I'm gonna do one
But if
with
he's
Chris
good,
Harris.
why would we
I'm not kidding you everything.
Smith? What's his last name?
Just say,
Chris something.
just say, stop giving you some.
Harris Fisher?
He's good.
How the car was
I don't know how to capture this, honestly. Before I say happy birthday.
I'm just gonna say happy
Yeah,
birthday and then
varsity
stop
will be
kind
good.
of slang.
I don't know anything about
Varsity's basically our grade.
Or not slang.
Yeah.
This is
That's weird. Because it is for almost every class. It's like becoming waves. And
Our grade in varsity is good.
You're average.
So
They're all
pretty
like
solid
6
at
foot
it,
or
which is
over.
weird.
Solid at everything.
We're better.
It's like when you go to school, it's about the same. Like the sophomore classes are pretty solid. And the juniors, there's not a lot of athletes.
Our grade is literally good at everything. They have sport, we're good at it.
It's just, I gotta say,
For the boys.
they go in the same waves. So like when you look at like certain groups, and I wonder if it was just because that group, like those ages, they were the ones that were doing traveling. That's what I'm.
Yeah, we did travel. We did
Because
travel
in
leagues.
ways where you don't have traveling leagues, those groups are usually weights.
What?
Yeah.
And championship.
Everyone's good.
Remember when Ray hit that?
What's
Sixth
your
grade,
picture using?
and Ray hit that really long half-court shot.
He hit two this year.
It was your first year in baseball.
Where was it at?
I don't even know if
Hey, somebody borrowed one of my calculators.
sat out
Please
there.
make sure I get it back at some point.
Yeah. He hit another one that you're in first.
Yeah, as against Forest City too, and also too. And I sat out
Hey,
there
remember,
too.
homework due Tuesday. Oh, I gotta tell you.
Oh,
Yeah.
That was the homework I gave you
Oh,
yesterday.
you won?
yeah.
I like when we're there two tournaments at once.
Yeah.
Somewhere I want to. You guys don't know that AAU tournament? Oh yeah. Yeah, but then you played like
And then I got another.
20 minutes.
Yeah,
Yeah, they're
it
20
was
minutes
super
halves
bad
as
one
long
time.
as
And then I got another call.
Because remember when we played at,
that one.
was it like Humboldt or something? And then
Oh,
we
no,
played
I
at
was
Osage in the championship game. And then I didn't have any of my stuff. And they're like, hey Jack, we need you to play. So I was wearing tennis shoes and Ken's black shirt with a number tape on the back.
I sat out that one. Ken would always.
North Butler.
Ken would be like, he'd be like saying next, then they'd start playing, and we'd get like start playing against him. Why not? And then some kids would sit down for the whole game
Yeah,
because
I
Nick
was wearing
hasn't played.
Ken's black shirt. I was like 2 sizes too small.
Okay.
There was tape on the back.
Relay message.
Yep.
That was at North Butler. That was
After
awesome.
the 1 minute lecture you get in.
They just destroyed Ocean first game.
Okay, shall we get started?
Yeah, they beat us, and us and Osage won the championship.
What?
I remember.
It was like
That was Bushbone travel.
It's like a resort.
I remember
to
the
Oh, God. Someone, I talk a ton of trash to
You tried to football, right?
No, I just like said it.
Well, yeah, I didn't hear it.
And he actually
I think you have the wrong guy. Okay, so where should we start?
Not that one, but
in football, I mix sandwiches. You got a good
I
guys.
got
Nick, you have to talk trash to Schwab. I'm serious. I hate him. He's the kid who drools.
I'm gonna go.
Drools in black.
I know you did.
Drools. Drools and turns around and walks away. Schwab and flex. I'm like, Schwab, you didn't do anything. You did not do anything.
Swish Swamp.
I hate
Remember last year I was got to Swish Swamp. Monty's like, Jack, you're gonna be Swish Swamp. Who's Swish Swamp? You know, that number 5, Swish Swamp.
I didn't know we had.
No, his name's Schwammen. Monty. Yeah, his real name is Schwammen. Last year when we ended the playoffs, Monty's like, okay, Jack, you're gonna be the scout team guy for Schwamp. And we were all like, who is that? We have no idea who that is. He's like, that number 5, Swish Swamp.
Read
I do
right.
too. Monty's my hero.
Nearly full pass. Got it. 5 points.
If be anyone in the world, I'd be Ryan Myers or Monty.
80.
Monty's my hero.
Give me a real quick.
Why?
Monty gives 0 hoots about anything.
We need to have alternate rules for each letter.
He was getting so frustrated yesterday with Anthony and John. Oh my goodness.
They don't listen though.
They don't.
Like, it's one thing, like, you don't know it, but you're trying. But they, like, don't listen and then... I don't remember.
It's like, honestly, you went to work at the other place. You did not?
Are you pro or against the pipeline? We're not ruining their land, we're putting a pipe under it.
Yeah, but we can do with their water.
There's like 24-hour supervision. It's like a bunch of crap that like modifies it. So, well, yeah, they say that, but how many?
But like,
We don't actually know if that happens.
how did
You don't look for a pipeline. Yeah, but there's already pipelines under there, and nothing's happened. And with the technology that we have, there's like valves that like shut off.
But we also have that in the ocean where we're going to get.
What do you think it was?